in listen-only mode.
Good morning, everyone, and thank you for attending today's webcast, Autodesk Inventor AnyCAD. Our presenter today is Keith Doran. He's a solutions engineer with Hagerman & Company. We're also joined by Matthew Nichols, who is going to help field questions. He's also a solutions engineer with Hagerman & Company. Before we get started, I want to let you know that you're in listening-only mode. If you have questions during the presentation, just type them into the question panel on the right-hand side of your screen, and they'll be addressed at the end, or Matt can address them throughout. As you exit the webcast today, you'll be prompted to fill out a survey, and we ask that you take a few moments to fill that out. And with that, I'll hand things over to Keith.
Excellent. Thanks, Ashley. So again, the topic of today is Inventor and AnyCAD. So what exactly is AnyCAD? It is an acquisition that Autodesk made in the last year that just allows them to open and function within neutral and competitive format files in a new and much more productive manner. So the first thing that I want to kind of show here is a little bit of a difference in functionality that Autodesk has kind of grown into the DWG environment first. And really this is just another way to utilize AutoCAD data within the Inventor space. So in this case, I've got just a simple basic part file open. There's nothing in here yet. And what I want to do is just start a sketch. And then as I do this, I now have the ability to insert some AutoCAD data within this space. I don't want to do. Where's my insert? No, that's not the one I'm looking for. I didn't. That's the tool after. Here's my command. Bear with me a moment here. Ah, yes, thank you. Having a brain fart today. All right, so the tool that I'm looking for is the insert DWG file into this space. And why am I'm not seeing the tool I'm looking for. Import 3D model. Import. There we go. Sorry about that. I was looking for my the wrong piece of information. So in this case, like I was saying, I want to import some information in here. In this case, I just simply use my import tool, and then I'm just going to browse to this DWG file. You know, in the old methodology, this would be a case of doing a copy and paste, or even going through using some of the full importation tools within the software. But now I'm just going to go in and do a hard import of this data, and then I'll just specify what plane I want that to exist upon, and then where I want my 0 point to land. And in my case, I just chose the 0, 0 location inside the model. Now, as you do that import of the DWG data, it is going to create this associative underlay. You can see here the entire AutoCAD file got pulled into the Inventor space. From here, I want to take that information and embed it into my sketch. So to do that, I'm just going to activate that sketch. And then from here, I can use my new projection tool, Project DWG Geometry, in order to bring that data through into my space. So in my case, I'm just going to select a couple of the edges that make up this design, like so. Once I have those entities, I can go ahead and then start using my drawing tools. apply dimensions to those pieces of geometry. And then use my other relationship tools to lock them together. Now, the important thing to note here more than anything else is that in the old methodology, once I imported this information into a design, this information was essentially hard-coded into the Inventor file, and it had lost its association back to the live DWG data. But this entire time that I've been working inside of this data set, in AutoCAD, I've had the file open. And in this case, what I want to do here is I'm just going to simply stretch this data to move its position in the part. So I'll select the geometry that I want to stretch, define my overall amount of stretch. I'll do 500 or so we can see that effect take place. I'll save the change that I've made in the AutoCAD file. Back over here in my Inventor session, the system has updated, letting me know that there is an update pending. As soon as I click my update tool, the DWG file associations will update, and the AutoCAD geometry will update, and my Inventor sketch geometry that's been associated to it will also transition to make the change. And the big thing here is this allows me to integrate AutoCAD file data as opposed to just straight importing it and having essentially dumb information at this point in the process. So for those users that are still in a hybrid type environment, this can really streamline those workflows, keeping those users that are still using the AutoCAD data or even utilizing small portions of the AutoCAD data to get robust Inventor data out of it. So with that, we're kind of seeing a little bit of that association or live associations, and that whole process just streamlines forward into the other file types. So when I go to open inside of Inventor, we know that we have a huge number of different file types that we can open. Obviously, our standard AutoCAD files or Autodesk documents. We can also open up a lot of neutral formats like IGES and STEP. And those file translation steps really haven't changed anything from the old version to the new. Right? You still import that information. It doesn't have any parametric data associated to it. But for a lot of this other stuff that we're working with, our Pro-E files, our Catia models, and SolidWorks documents, those data sets can be utilized in a new way. And this is where that AnyCAD functionality comes in. So in this case, I've just changed my files of type to SolidWorks, and we can see in here kind of a real small thumbnail of the tank assembly that I'm about to load. With the reference model, however, this is going to create a live association to the SolidWorks or other format file that you choose, Catia and Pro Engineer. In this case, we can dictate what types of objects we want to bring in, solids, surfaces, work objects, and so on. And then beyond that, we can come in and associate or specify what pieces of this model we want to load. In this case, this tank has a number of fastener components that are really just going to bog down my session, not really gleaning anything relevant out of them. So in my case, I'm just going to come through and select all of these objects. And now that I have all those objects selected, I'm just going to change the status to exclude them. In doing that, it'll turn them gray. You can kind of still see a preview of them in the space, but they are not going to get loaded. Once I've got this operation completed, I can click OK in here, and it's going to perform the operation, creating the associative link to this tank assembly file. Now, it still does the same workflow it used to do as far as creating your translation reports. So in this case, if I wanted to read that data, I simply have to open the translation report. And we can see in here that we've got some files that loaded, some of them that didn't load quite as well. In this case, I think there's a face simplification. Actually, there's a body missing from that solid part file. So in this case, it got skipped. Okay. But we can see in here this is a SolidWorks 2015 file. So again, in keeping up with all of our current versions, when 2016 AutoCAD or Inventor came out, it could now read the 2015 SolidWorks files with no issues. So in here, I'm just going to do a quick save of this file set, and I'm just going to call this tank assembly just to kind of match the naming convention from the SolidWorks file. Save. So in here we've got our tank assembly, and as far as utilizing this data set, I'm still in an assembly file. I can still work within this space as necessary. So if I wanted to create new components from scratch in here, I can do that. Just make a new standard part. Specify a face we want to work off of. Maybe start sketching inside of this space. Project some geometry off that data as necessary, and so on. Right. And generate those components. Okay. Again, same functionality as a standard assembly file at this point in the process. Now, the important thing to note about this is that this is a live associated file. So on the other side of the coin, if that SolidWorks user were to open this design and make any kind of changes to it, as soon as they save those changes back to the SolidWorks file, I'm going to get notified of that change immediately. So in this case, Matt was nice enough to use his seat, and he made a change to this assembly, and we can see over here that there is an update that's pending. All I need to do is perform an update, and we can see in here that tank extended in length. All of my other associations that I'd put into this model are still there. In this case, it was a very basic change, just an overall length value that was updated. If, for example, it was a part that got completely swapped out for another part, just like in an Inventor session, those relationships that bind those designs together are obviously going to cause some problems, right? If I take a square part and replace it with a round part in Inventor, I'm going to lose relationship data, constraints and joints and so on. The same sort of thing would hold true here, right? But size change definitions, positional definitions, all of those changes aren't going to really affect your constraints per se. All of that's going to trickle across. And again, that SolidWorks file can be edited in its native format, in its native software, and Inventor will update the designs as necessary. I don't have to retranslate these files. I don't have to do any of those types of workflows. It's just automatic. And that's where the huge advantage of this comes into play. Now, in my workings with this function or working with this process, there's another aspect to this that I have come across. Right? Obviously, this requires the files to be saved and then overwritten on top of themselves. So say, for example, you're receiving these neutral formats from a third-party vendor, and they're updating their designs, and you want to keep both versions of the document intact, right, where you have a new tank and the old tank, and they're separate assembly files, right? Well, all you would need to do is essentially create this assembly file, and instead of bringing in the parts that you're going to work with it, and I'm going to go ahead and get rid of this guy and save that. And instead of making your assembly in the context of this design, you would simply create a new assembly file and insert it into it. And we'll just crown this at the origin. Okay. And now that I have that master assembly that houses the imported data, I can then grab this file and do things like my component and replace. And in this case, I've got a new tank design that I've already created, which I can easily come in and swap back to a different size of the file. Now, the reason that you do that is that the original imported file, there's no component replacement tools available, right? It's simply the original document with the relationship, and it's a much easier management to have the separate files managing the separate documents, right? In this case, this new tank assembly has a new SolidWorks file, and those two files are associated to one another. Now, if you did want to disassociate these designs, it's just like a derived relationship. All I would have to do is select that tank assembly and come in and either edit the importation, or I can specify which objects within that space get imported. So somewhere down the line, I could go in and re-add those fasteners if I required them. I can also come in and suppress the link or straight break the link. And in breaking the link, it is going to want me to specify where these files are getting saved. So essentially what you're doing is you're taking it out of the reference mode and you're bringing it into a conversion mode, where I'm actually going to take the SolidWorks data and convert it into new solids. So in this case, I can come in, specify where I want the tank assembly to get saved. And then it's going to go through and create my assembly with all of the pieces within it. So this is, breaking the link, just like in a standard relationship, you are disassociating it from the original models. Same workflow applies here. It's now its own unique objects, and does the hard import, creating a dummy set of files. So kind of working off that same workflow, the next thing here that I want to look at, I've got a couple of part files that I've worked with, and in my case, I do need to change this to all types. So from here, we'll go ahead and open one of these parts. Pro Engineer. What are you doing? Come on. There we go. Wasn't selecting the files for some reason. So in this case, just like before, I'm getting the option with this Pro Engineer document whether or not I want to reference the file in, or if I want to do a conversion of the document. In this case, it is a reference model that I want to keep association to the Pro Engineer file. I don't need any surface data in this case, so I'm just going to turn that off. And when I hit OK, it's going to import that part file into my space. Now, on immediately looking at this part, I've got a pretty good idea that this is probably a sheet metal component. Right? Obviously, with the importation, it brought it in as a standard object. Now, one of the other enhancements that they've made to the sheet metal functionality when you're dealing with imported components is that it will automatically measure a design during the creation of it. So in this case, I'm going to go ahead and tell it convert to sheet metal. And in years past, you'd get a dialog box that would say something along the lines of, hey, if this part is not uniform thickness and you don't define the thickness in the style, it won't work. Right? Well, in 2016, I simply tell it I want to make a standard part, a sheet metal part, and then it allows me to select geometry inside the model, which in turn updates the thickness so that it matches. In this case, I'm going to go ahead and use that thickness that I selected from, and in this case, all I did, in case you missed it, was I selected one of the main faces of this object in order to get that thickness value. When I hit OK, it then updates that sheet metal style. In this case, I'm just going to define what side I want to be my alpha side, and then from here I can flatten that component. And the important thing to note about this is that this workflow can be applied to any of those imported components, right? It's just a streamlining of the number of steps, right? In years prior, you'd have to go through and measure the value and confirm whatever the wall thickness of that part was supposed to be, or the sheet metal thickness of that component was supposed to be, then go into the sheet metal styles. Plus, you had a harasser dialog box in the middle of all of that, reminding you of a workflow that you probably already knew, right? The other big thing to note about this is that this file is in fact a live file. So if I were to go into a Creo session and edit this sheet metal component, I would get the same updates inside of this space where I could go in and adjust the sizing positions of it. Beyond that, because it's a functional solid, I can come in and perform operations on this part as well, making adjustments on it as necessary. And then in this case, we'll just use our sheet metal cut tool to cut through that thickness apart and update that solid. So it really just allows me to flush out an existing solid part without having to break the association or the associative link to that data. And again, if I did want to break the link, all I need to do is just right-click and break the link to that document to go ahead and do that. just checking the questions list here a second to see if there's anything. Man, how do I get this thing to? Here we go. So the first question here is with other files that you're receiving, the versioning of those documents, and like I mentioned, the way that I've seen users address that scenario is to have a separate file that you import separately in the design. So like in this case, this N44892 file, if I needed a new version of it, right? If I had a different file from the customer, instead of trying to update this document, because this is a hard-coded relationship or a hard-coded link to these two files, what I would do is I'd start a new document, and by just simply opening the next file in the list. Now, these two PRT files are different from one another, so this is not going to look the same, but the process is exactly the same. So from here, I'll just do another reference and then import that other file in. Now, by doing this, if I were to use these parts within an assembly file, I can easily just do a component replacement and swap those designs. So some other questions that have come up a couple of times is, if you modify these components, in this case, I went in and added a couple of rectangular cuts to this model, is that going to show up in the native formatted file? No. Right? These are features that have taken place in Inventor after the importation of that document. They don't translate back to their neutral format, so they don't go back to, Catia or SolidWorks or Pro-E. And yeah, Yeah, so the question is if I bring in a model and inside of, or using this AnyCAD functionality, and I want to make massive levels of changes to the original design, at that point it's really just a bigger question of who do you want to control the models, right? Am I trying to create an associative link to the SolidWorks document so that the SolidWorks users can continue to make changes, or am I going to gain control of these models after they've been imported, right? If the answer is the latter, where I want to gain control of these models, then you should be using the same methodology that you were using in the past, right? Just hard importing these files and then making any modeling adjustments using your standard modeling changes. If you want the SolidWorks users to be able to control their models parametrically and you're simply seeing those changes live or seeing those changes after save, then you would want to use the referencing functionality, right? That creates that association and it's not breaking or making dumb solids. And again, regardless of what software it is, if I go in and start making adjustments to these models, it's not going to be anything that's going to translate back to the originator files. So those SolidWorks documents, those Creo files, they're not being updated in any kind of way. It's just simply how is it reading the information and how is it coming through. And just to kind of show here, I'll go grab a step file. Got stored a whole bunch of these documents. No, not that. whoops, I grabbed one that was already there. So with the open function here, I'll switch this back to SolidWorks, and then I'll select that part file. And as I open that, the same functionality applies as far as whether or not I want to bring it in as a reference. Meaning, do I want SolidWorks to be able to make changes to that file, or do I want to import it, allowing me to truly control the model itself and make changes to it, right? In this case, if I go to load, it'll show me the data that's made up of that part. And in this case, I just grabbed a very basic C-channel shape. When I bring this in using my conversion step, I get a majority of additional steps that come through as far as how do I want to work with this process. So in this case, do I want to specify how I want these to get imported in? So this is kind of like the old, if it can't heal a solid, what do you want to do with the surface data that it comes through? Do I want it to try to composite them together, or do I want to use the construction environment? And because I'm using the convert model function, I have to specify where I want these files to get saved. Now, the one thing that I've noticed in here, the big thing that takes place, you have to pay attention to where these files get stored. It will override files that are there. So if I were to convert this file once, it's going to make a part file called the name of this document.ipt. If I do the same process again, it's going to import right over the top of the same file. So it's always a good idea to make sure that you're saving these files into an imported components directory or into a directory named the design files, because it does give you some functionality change in here that you got to pay attention to. This is different from years past where it would just utilize the files. This will actually overwrite them, which can be kind of problematic depending on what files you already have in that location. Okay. On the selection page, we get the same functionality on either or. So with the convert function or the reference function, we still have a visualization to see which pieces of the puzzle we want to import. This is kind of nice, if you get a big design from somebody and they've got all of their fastener data or all of the standardized content in it, and it's really just bogging down the system. This gives you the ability prior to actually importing the data to select which pieces you don't want and weed them out by simply using your exclusion button to exclude those objects out of the import steps. So from here, I'll go ahead and import this solid part file, and we can see it brings it in as a dumb solid, just like our old legacy process inside this space. And as I save this, because of my workspace directory, this is getting saved right in that root directory as that part file. Okay. Get this out of the way for a second. From here, if I wanted to go in and adjust objects, I can do a number of different things. Maybe I want to make this whole diameter something different. I can figure out what the overall diameter is or measure it, and then I can use a number of different functions in here, move face, move bodies, thicken offset. In my case, I'm just going to shrink this hole. If I select the right face, there we go. And then I can specify I want to make it a 1/2 inch less. So it's going to take a 3-inch diameter and take it down to a 2-inch diameter. And then as I remeasure here, we can see that effect on the part. Right? If I wanted to move that face, all I have to do is go in and use my move face command, direct edit in this case. So I select the faces I want to work with, and then specify the amount to move them to change their positions right inside the model. When I'm done, I can just simply close it. And again, those are features that are taking place within the Inventor space. They're not taking place in the original SolidWorks file. In this case, this was a dumb imported document. So this is a new solid, completely disassociated from the SolidWorks importation. if I go through and I can repeat those exact same steps on a reference model. So I'll go to Open, grab that same SolidWorks file, and in this case, instead of converting it, I'm going to tell it to simply reference the data. I'm going to lose a lot of my import options, but the data still functions the same way. So in here, I'll use that same thicken offset command, specify the same value as before. I'll go into my direct edit tool, select the faces I want to manipulate, specify the amount of movement, and they function exactly the same way they did before, right? And again, this doesn't write back to the SolidWorks file at all. It's just simply a way to update these designs as necessary. So now, the one gotcha here is if I've taken the initiative to make these edits and I've used the import function, right, the reference import, and then the SolidWorks user takes the initiative to make these changes, I'm going to stack them, right? So my part in turn is going to end up with a thicken and a direct edit that's going to shrink that hole yet again and move it yet again. So again, this is all about ownership, right? So you have to think about, am I gaining control of these files, and do I want to stop the neutral format or the third-party software from being able to make edits to these files, right? If you decide I want to make changes to these are my files and I want to work with them, even after the fact, all you need to do is break that link and disassociate from the SolidWorks file, right? Otherwise, it's more of a communication thing. Now, it wouldn't be the end of the world if they went in and made the change, since in all reality, all I would have to do is grab these features and suppress them, and then the part would revert back to their edited version as opposed to the stacking of them, if that makes any sense. Is there a change in the legacy issue with 2016? Will files be backwards compatible? No. Just like in the 15 versions prior to Inventor, to this version of Inventor, as you save the files forward, they are not backwards compatible with prior versions of Inventor in the system. When you were showing the link from AutoCAD to Inventor, will the changes you make in Inventor be translated back into AutoCAD, since both softwares are from the same developer? So in my case, I was simply utilizing that information to create the file. So we'll go back into that file here. I don't think I saved it, which is okay. Dwg Underlay. So we'll import the AutoCAD file. Come here, you. So as you do this underlay process and you create that association between these objects, the data that's from AutoCAD is not editable within this space. So there's still a little bit of ownership that's going on inside of this design space. So if I were to go in and, I can't really edit this per se. I can come in and measure it and suppress the link and even break the link. Now, if I do break the link, this is going to do essentially what the old process used to be, where I would go into AutoCAD and copy the geometry that I wanted to work with and then paste it in here, right? Or I would go in and use the open DWG and use the import wizard to specify the geometry. And as I do that, I'm going to get some additional functions if I were to break the link here, where I can go in and tell it to add constraints and auto constraint endpoints and that sort of stuff. But in all reality here, this is a DWG file that's simply being viewed in Inventor, right? Similar to the way that the SolidWorks and Pro Engineer files are still SolidWorks files and Pro E files. They're just being viewed inside the software. So the data doesn't translate back in any way, shape, or form. Parameter values do not come across. So in these documents that I've been working with, these do not have any kind of parameters associated to them at all in the space, right? On the part file that I worked on, This one here, just the parametric changes that I made to the part. This is the thicken offset. That's the move face. So yeah, no parametrics yet. I don't know if that's coming in the future or not. That'd be great if it does. That would really help streamline a lot of additional modification functions. But in this case, the workflow is still just essentially a step above importing the files directly. So I know it's a relatively short exercise here, or short presentation, but the functionality of this is very, very powerful, being able to utilize this space, especially if you're in a collaborative environment. I work with a lot of customers that have both software or multiple iterations of software. I work with one group, I'm in Indianapolis, and work with one company downtown. They've got Catia stuff and Pro-E stuff and SolidWorks stuff. And to be able to take that information all into one space and work with it is very powerful functionality for them. Beyond that, this tool does allow you to do that, right? Where I could, in this case, if I had a tank assembly that was directly linked to a SolidWorks model, I could make another assembly file that's a direct link to a Creo model or Catia file and bring both those documents in and constrain them together, and I'd still have associative links. So if those models were updating, I can then perform those updates at this level, allowing those to work together. DGN files I've not heard anything about. The other file type is the Solid Edge Siemens Systems, which I don't think it's called Solid Edge anymore. It's got a new fancier name. That I don't believe that functionality is there as well yet either. But I'm sure Autodesk is working on trying to get as many formats into this AnyCAD environment as possible to just streamline and make their workflow more robust in the space. And as far as the webinar, I believe that they get everyone who's participated in the audience gets an email that has the recording of this. Ashley, is that accurate?
Yes, that is accurate. Everyone will receive the recording.
Okay. Okay. Excellent. So the first question was, can an IPN file be created? I've got this tank new assembly file that's got the referenced document within it, and it does have those referenced parts, so let's just give this a try. I've honestly not done this, so I'm not sure what it's going to do with an existing document like that. So let's go grab the tank new. If you've not seen the changes to presentation space, it's been completely overhauled as far as the overall workflow and interface is concerned. So the auto explode, if you have a design that you've worked on, and it does a much better job, honestly. I've taken a couple of designs and stuff that I had to manually tweak apart. I use the auto explode, specify what number of levels, and this uses the bill of materials to kind of control that. It does a pretty decent job of doing it. So definitely give this a try. Try the auto explode in the new version if you haven't done so yet. But from here we'll go to tweak components. And in this case, I'm just going to dictate a direction and just grab some of these parts here and see if I can pull them apart. Yeah, it doesn't look like they're going to. Now, if I take my other file that I created, so in my case, I've got this tank assembly that I converted, not referenced. This one I know for certain will import into here without any issue. So this is the tank assembly file. We'll go into tweak components again, and now you can see there, come on now, I want just the one part. Explosion, assembly, tank assembly, tweak component. I want just this one part. There we go. For some reason it was trying to grab everything at the same time. This is all one big piece, so so yeah, all the individual pieces of this design are in fact pullable, tweakable in this case. And again, that's because of the conversion. So it looks like, as far as on the surface, if you use a reference model of an assembly file from, at least from SolidWorks, it will not pull it apart. 2016 can import Catia files with all related data, not just a dummy file. I'm not exactly sure what you mean by that, by the statement for the Catia question. I've got that selected. Let me do this. If you have in this case, go ahead and just shoot me an example of that so I can kind of see it. This would be something off-site here. No, the GD&T information on the 3D files do not come through. It's just the solid information. And as far as exploding solid bodies of a part file, the answer is it's still no. The easy answer for that is use the make components command and then explode that to create the skeletal model. As far as step files are concerned, they're going to be treated the exact same methodology. So in this case, let me go grab a step file here. Here's a real basic one. Some of those files are quite large, so I want to make sure to grab one that's not real big. All right. Open. So, got my step file here. In this case, you'll see there that the reference model is not even available, right? And this is because it's not a file that can be referenced, right? Step files, IGES, SATs, and STL files are neutral format documents. They don't have a parent software that created them, right? It knows who created it in the data set itself, but as far as the way that it was created, it doesn't have any parametric data. It doesn't have a parent software that can edit those files parametrically. So in this case, I'm just going to tell this to import it as a solid. Right in the root directory is fine. And again, that load model is really nice since you can see what it's going to load kind of prior to the actual importation step. So in this case, I can see there's just a really basic component. And as I bring that in, if I want to start making changes to this, we can do some direct edits, or we can use our thick and offset tools to perform those. So in my case, I'm just going to push that guy out. Come on. You're being stingy. So let's add a quarter to the end of this part. Right? If I wanted to change these diameters here, I could use maybe my direct edit and grab those faces, change their scale. Oh, it's only solids with scale. Size. I want size change. There we go. And then I can adjust those values, making it 1/8 of an inch radius larger, so 1/4 inch diameter larger. So again, neutral format file, imports just like your standard workflow. The dialog boxes have been refreshed just to kind of keep them in line with the rest of the interface, but otherwise the after the effect edits are still available. So the documentation features, oh yeah, absolutely. So if I were to go to a new drawing file, and in my case, I've got my sheet size set to something really big. This should be okay though. We'll go to base view here, and I'll grab that new assembly. This one is still imported, right? So if you haven't seen the 2016 drawing view interface changes, this is pretty amazing stuff that they've changed. I was a little hesitant at first when I saw it because it was just like, holy cow, this is way different than what it used to be. but there's a lot of stuff going on in here. But as far as selecting views, I can simply select the views during creation. If I decide I don't want one, I can just click the X on it, it disappears. If I want to change the view orientation of this base view, I have my view cube available to allow me to do that. So in here, I can select locations and rotate, and it rotates all the views on screen automatically. So it gives you a nice interface to kind of tap into as necessary. The boundaries that wrap around these allow you to change the scale, and you'll notice that it jumps to stock scale values. So this is based on your drawing standard. So inside the standards, you can specify, what those scales are available to you, and then it'll only use those to do that. But again, you can see in here creating those view scale or those base views and secondary views is very, very easy to do in here. And as far as working with projections and other functions in here, in my case, I created a projected part. All I did is I stole a face to make a new face on a new design, so I created an adaptive design. Same scenario with anything else. If I were to go into that design and I totally change the shape of that circular face to create that gasket part, it's a complete crapshoot whether or not it's going to work in the future. If they add new holes or they move holes around or they completely take something out of a system, I still have those face IDs defined. If those object IDs are gone, it's just like any other assembly replacement step. It's going to cause downstream relationship errors inside that space. As far as the threaded information from a SolidWorks file, I don't know for certain. Let's see, do I have a tank assembly that's not busted? Matt, can you open this up and thread one of these holes? And this is the tank assembly new assembly file in the new design. So the way that these handle in the vault is it's all integrated. So basically, if I were to activate the vault on this on these designs, it would simply treat those objects as children. So it would bring those SolidWorks files into the vault and maintain the relationships as if it were a part within the assembly. With that, the check-in and out operations still take place. You would have to get the SolidWorks users the access to those files if you wanted to have them check in and out the documents, which does require some setup inside the space to do that, but otherwise is a pretty straightforward workflow. And yes, the copy design functions as well in here. The big thing there is just making sure you work with the copy design interface to specify what objects are copied inside of that space. So, new SolidWorks design, new entries within it. And there is some plugins that work with the Vault. I don't believe Vault Basic can handle the full functionality as far as being able to truly to capture the full breadth of like SolidWorks and Pro Engineer file relationships. But the higher level of vaults have plugins that can be added relatively easily inside that space. Matt's currently tinkering in SolidWorks. We'll give him a second to finish it. And on my side, I'll know when he's done because it'll immediately tag it with a lightning bolt to let me know that it needs updated. Okay, so I'll have to re-import the original one. Bear with me a second. Open SolidWorks stuff, tank assembly. Open this reference model. We'll go in and specify which pieces we don't want. In this case, I don't need any of this threaded. I'll leave one threaded nut and one. Let's just turn all of those off. And then we'll go find that part. We'll see if we can find the matching bolt that goes with it. So we'll include that guy too. And then okay. All right, Matt, which one did you thread? So I can kind of try and find it. $1 o'clock.
Your mouse is right there.
Yeah. So it pulled something through for the thread designation, but it didn't actually pull real thread data. Yeah, I hadn't done this before, so I wasn't certain what the definitive was going to be on that part. What'd you do there? It's off kilter. So yeah, it looks like the thread information does not trickle across through the AnyCAD importation. But again, as far as doing things like you know, adding constraints, adding objects inside of here, you know, if I were to bring a gasket component in and bring a component gasket in here and constrain it to it, if that were to move positions, rotate around this part, move up and down, change diameter, those sort of changes wouldn't necessarily change the face IDs, so all of my constraints and joints would trickle across. Now, if they went from a round one to an octagonal one, then the whole thing's going to be a wash, right? Because all those faces are going to change. So it's really just dependent, just like in Inventor, on what the changes were made. As far as the A360 site, if you set up your if a user were to upload a SolidWorks file to the A360 site and you were to download that file and use the A360 folder structure, if they updated their document and you updated your synchronization, it would in turn update the Inventor files. And it would be anyone who has ownership of that document on the A360 space. So a lot of very good questions. Does anyone else have any questions? We'll give a couple more minutes for any last trickles of questions to come through. All right, so over the last hour, we've gone through a number of the different workflows that are directly related to the AnyCAD acquisition and functionality and that's been embedded inside of Inventor, as far as bringing in a DWG underlay and utilizing that geometry and seeing it update when the AutoCAD file is saved, importing Inventor or SolidWorks documentation into the Inventor space, selectively deciding which components thereof we want to work with, and then seeing it change live when the SolidWorks file is updated. We also worked with some ProEngineer documents and saw some of the enhancements to the sheet metal functionality working with imported components. Lastly, we saw some of the different workflows for using those files in different iterations. So if I have a file that I want to keep maintained as a second document or something to that effect. So the one last question here I'm seeing is AutoCAD Solids. It's the same workflow as before. You would just go through the import process and import them in. You know, it's dumb solid, so it's not going to do anything fancy as far as working with those inside the space. So again, thanks everyone for attending, and like Ashley had mentioned, or I mentioned earlier, you will receive an email with the link to the data. Is that accurate?
Yes, it is. You will receive a recording, and also if you have any questions you think of later, you can respond to the confirmation email you received from GoToWebinar, and we can get those to Keith and Matt to help you. And once again, if you could take a few moments to answer the short survey, we would appreciate it. It will automatically appear when you close down the session. And other than that, thank you for attending today's webcast and have a great day. Thanks, Keith.
Thank you.